We're going to be looking at signals from the sun and trying to identify, is this really the solar flare that we want to target with the telescope we've been working on for 3.5 years. A sounding rocket is a rocket that will put a payload, in this case our telescope, up into space for about 5 minutes to make observations of the sun. This has never been tried before. There has never been an effort to try to capture a solar flare in progress with a sounding rocket. A solar flare is a bright burst of light from the sun, and that light might not be just in the visible light that we can see, but it can be across the entire electromagnetic spectrum. We have been putting a lot of time and effort over the past couple years into answering the question, what is the earliest signature of a solar flare that we can look at and react to in near real time? So what we look at are low energy X-rays from a NOAA satellite called the GOES satellite. And we can get these data within a few minutes of the data being taken on the satellite. We don't know when solar flares are going to happen. The X-rays can give us a clue into that, but they happen very early in the flare because they're associated with the energy release that kicks this whole thing off. So in order to study those, we need to try to observe the X-rays as close to the start of the flare as we can. I would say that the main thing that's special about the University of Minnesota in terms of being able to lead projects like this is the long traditions and history of the space physics group here in the School of Physics and Astronomy. So there have been space physicists here in the department ever since the start of the space age, and actually even before that, a lot of high-altitude ballooning things were pioneered here at the University of Minnesota. So I'm just happy that we're able to continue that tradition.